Welcome to yet another video, guys. And this is 6 days to finishing school. And the topic for today is time and work. So let's see what we'll be looking at in time and work. So these are the subtopics that we'll be looking at. First, we'll have to learn what is proportionality and how is time, work, and efficiency related proportionality wise. Okay, is time and work directly proportional, or is work and efficiency directly proportional? So I want to just clear that stuff out so that you guys know what is proportionality, and you also should know what proportionality. There are two types of proportionality, so we'll look at all those things. That is the first thing we'll do. Clear out the proportionality doubts for all the students. The next one we'll be doing is looking at how time and work and time, speed, and distance, although it may seem like two different topics, the basic formula that you use for time and work and time, speed, distance is the same. So if you want to understand what it is or how it is, stay tuned for that part of this video. The next one is time and work. If you've heard about time and work before this, the usually we have two methods to do a problem in time and work. The first method is what we call as fractional method. As the name suggests, it involves fractions. So that is why it is called a fractional method. The same type of question can also be done using the LCM method. As again the name suggests, we'll be finding out the LCM of few things and then we'll try to solve the problem. But both the methods are two different ways of solving the same problem. So it is sufficient that if you know only one type of method, just one fractional method, if you are thorough in fractional method, it is sufficient. Or if you find that LCM method is easier, you could do it. But what I'd suggest is, I'd suggest you to learn both the methods. It is not at all difficult. It is very easy. Now, by learning both the methods, what is happening is you are able to pick and choose the method which if applied for a particular problem will give you the shortest number of steps or a lowest number of steps. Okay, sometimes a problem can, if you use a LCA method for a problem, it can give you lots of steps. LCM method can give you lots of steps. Their fractional method will give you answer within 2 steps. Okay, so that will save you time. Okay, sometimes in some problems fractional method will make it difficult for you to solve the problem. Although you could solve the problem using fractional methods, it becomes difficult. So what you guys do is learn both the methods, and whatever is comfortable for you, you apply that method. Whatever you feel is apt for that particular question, you apply that method. Okay, and learning both the methods also helps you understand the concept of time and work. Now, the final one is man-hour work method. This is a very important formula that you can apply for some of the time and work problems. We'll see what those problems are, but this is a very important method, so we'll be looking at that also. And finally, we'll look at some problems on time and work. So the first thing that we are going to look at is the what is proportionality and how is time, work, and efficiency are all related with each other proportionality wise. Okay, now this first statement, pay close attention to the statement. Now this says time is directly proportional to work done under constant efficiency. Now before we move on, guys, for those of you who don't know what is proportionality, I'm going to give you a little preview of what is proportionality. Okay, now proportionality is of the two different types. One is direct proportionate, and the other one is indirect proportionate. Okay, now how do you differentiate between these two, guys? So I want you to differentiate between these two. For example, let us take this example where you have price per kg. Okay, now this is price per kg. Now this is quantity. Price per kg. Okay, or yes, quantity. You could take this as quantity. Yes, this is quantity. Now, guys, if 2 kgs, okay, let us suppose the price per kg is 50 rupees. Okay, price per kg is 50 rupees. Okay, or okay, guys, let's have a look at this. Now, take these uh, things. I would say price per kg, quantity, and sales. Okay, I hope you know the relationship between them. Now price per kg multiplied by quantity will give you what? It will give you the sales. Okay, for example, the price per kg is 50 rupees. 1 kg is the quantity. Now how much will you pay for it? You will pay 50 rupees, right? So that is the sales. The selling price is called the sales, or the price at which you buy is called the sales. So here what is happening is, now, see, there are three variables here. One is price per kg, the other one is quantity, the other one is sales. In these three variables, if you have to find the relationship between any two variables, okay, let's say price per kg and quantity, you are, or I can we take price per kg and sales. Okay, so if you want to find the relationship between price per kg and sales, so you're trying to find the relationship between this price per kg and sales. Okay, this is what you're going to find. Are you what are you going to find? You're going to find if price per kg and sales are directly proportionate or indirectly proportionate. That is what you're going to find. Now usually what happens is, when you have to find it, you'll always have to keep a third quantity constant. So if you have a look at this, the quantity in all three cases is 1. So you can clearly say the quantity here is constant. Okay, so whenever you find the relationship between two variables, in this case price per kg and sales, what happens is you have to keep the third variable as constant. So here I'm keeping quantity as constant. Now what we try to do is, now try to increase one thing. Okay, try to increase price per kg. You can either increase price per kg or sales. Okay, you can increase any one of those two variables. So when you increase price per kg, what happens to sales, guys? Sales also increases, right? When you increase price per kg from 50 to 100, sales increases from 50 to 100. Similarly, when you increase price per kg, when you increase sales from 50 to 100, price per kg will also increase from 50 to 100. All this is because the quantity is constant. Okay, not only that, if you try to decrease from 100 to 25, price per kg is decreased from 100 to 25. Now what happens? Sales also decreases. Okay, now this is what we call as directly proportionate. Okay, two variables are directly proportionate if when you increase one thing, the other thing also increases. You decrease something, the other thing also decreases. So here, as you increase the price per kg, sales also increases. As you decrease the price per kg, sales also decreases. Okay, so this is why we call price per kg and sales as directly proportionate. Okay, so price per kg and sales are directly proportionate. Okay, using this we'll do some things. This relationship between two variables being directly proportionate and indirectly proportionate is going to help us understand or solve problems very easily. Okay, so I'll show it to you how problem solving becomes very easy once you know what is the relationship between two variables. Now we look at what is indirectly proportionate. Now when I say talk about indirectly proportionate, so we'll take the same example. So you could look at the thing which is at the bottom. So this one. Okay, here. Now, which one do you think is the constant, guys? This is constant. I've kept the sales to be constant. Okay. Now we are going to find the relationship between price per kg, okay, and quantity. This is what I'm going to find. I'm going to see if price per kg and quantity are directly proportionate or indirectly proportionate. So what do? I either increase price per kg or increase quantity. Okay, so what I'm going to do is I'm going to decrease quantity. Okay, so just for the sake of looking at it in a different way, see, now I'm decreasing the quantity from 1 to zero point 0.5. Yes, this is a decrease. Now, when you decrease the quantity for constant sales, what is happening to price per kg? Price per kg, guys, is increasing from 50 to 100. It is an increase, right? So when you decrease the quantity, price per kg is increasing. Okay. Now, when I increase the quantity, look at this, from zero point 0.5 to 2, right? So from 0 0.5 to 2, I'm increasing the quantity. When I increase the quantity, what is happening to the price? The price is getting decreased. Okay, so this is indirectly proportionate relationship. Okay, when you increase something, the other one decreases. When you decrease something, the other one increases. Okay, when you increase the quantity, price per kg, sorry, when you decrease the quantity, price per kg increased. When you increase the quantity, price per kg decreased. Okay, the same will hold true if you do it the other way also. Okay, so let us try that also. You increase price per kg, what should happen to quantity? It should reduce. If it is indirectly proportionate, it should reduce, and it does. Okay, it reduces. And if you decrease the price per kg, okay, like in this case you are decreasing the price per kg, so what is happening is the quantity is increasing. So this is what we call as indirectly proportionate. Okay, so I hope you understood what is directly proportionate and indirectly proportionate. This is a very key concept you understand before we move on to all time and work and time speed distance problems. Okay, so we'll move on. So here we have time is directly proportionate to work done. Okay. Now under constant efficiency. So the three variables here we are worried about is, the first variable is time, guys. The second one is work done. The third one is efficiency. Okay. So very similar to price per kg, very similar to price per kg, sales and quantity. So here we have three variables, which is time, work done and efficiency. Okay. Now sometimes efficiency is sometimes called rate of work. Okay. Or work done per hour. Okay. Now pay close attention to this. People often confuse this and this. Okay. Now work done is not the same as work done per hour. Okay, work done per hour is not the same as work done. Okay, work done per hour is like the speed at which something is getting done, or the speed at which the work is getting done. That is why we call it rate of work. Okay, and but work done is not the speed, it is the amount of work which is being done. Okay, so usually this is very common in a time one work circle. We'll call it the rt equation. What is rt equation, guys? This is the rt equation. Okay, when people talk about rt equation, it is this. Now what this equations means is, now a is nothing but the amount of work done. This is a. Okay, this is equal to rate of work multiplied by time. Okay, so this is the this is how art is expanded. A is for amount of work done, r is for rate of work, and t is the time. Okay, so let us say somebody, to just give you an example of this, let us say somebody eats, let's say somebody eats 100 chocolates per hour. Okay, this is the rate of work. Okay, that guy is eating 100 chocolates per hour. Okay, now the time it takes is he 15 hours. Okay, so he does this for 15 hours. The time he eats is for 15 hours. Now what will be the total amount of work which is done? The work that will be done is eating 1500 chocolates, right? The total amount of work that is done is eating 1500 chocolates, guys. So this is how I define this rt equation. Okay, amount of work done, rate of work. Now this is why I said rate of work is different from amount of work done. 100 chocolates per hour is different from 1500 chocolates, right? So that is why work done per hour is nothing but rate of work. Work done is 1500 chocolates. Okay, so work done is 1500 chocolates, or work done here to be precise is eating 1500 chocolates. Okay, so work done per hour is 100 chocolates per hour. Okay, now time is 15 hours. Like I told you, this 100 chocolates per hour is sometimes called as rate of work, is sometimes called as work done per hour, and mostly most of the time called as efficiency. Okay, so that is why you put it in an yellow color, which says efficiency is also known as rate of work or work done per hour. Okay, most of the times they'll refer to it as efficiency only. Okay, but sometimes very rare, in on rare occasions you will find that they'll talk about rate of work and work done per hour. Okay, they all mean the same thing. Now let's take a close look at the relationship between how time is directly proportionate to work done, guys. Okay, so let us assume, so when we have time, when you are trying to find the relationship between time and work done, you know that we are going to keep efficiency as constant. Okay, so here we are doing efficiency as constant, so you are going to assume efficiency of eating 4 chocolates a minute as constant. Okay, so that is not going to change. So we look at time and we look at work done. Okay, let's see, well, let's increase time and see what happens to work done, and let's decrease time and see what happens to work done. Okay, you can also increase work done or decrease work done, and do vice versa and try to find out. So half a minute, how much of work will be done, guys? You know, work done is time into efficiency, right? R into T. Yes, so half into 4 is 2 chocolates, correct? So see, you have 2 chocolates. For 1 minute it will be 4 chocolates. Okay, so because the efficiency says 4 chocolates a minute, for 2 minutes it is going to be 4 into 2, 8. Okay, so you're going to have 8 chocolates. Now have a look at this, guys. Now we'll see what happens here. Now pay close attention here. When time is increasing, in this case time is increasing, the number of chocolates, what is happening, it is also increasing. When the time is decreasing, for example, from 2 minutes to 1 minute, if you decrease from 2 minutes to 1 minute, what is happening to number of chocolates? It also decreases from 8 to 4. Okay, so as time increases, work done increases. As the time decreases, work done decreases, and this is why I call this directly proportionate. As you can see, as time increases, work done also increases under constant efficiency. Guys, if you don't keep the efficiency constant, then this won't happen. Okay, so you must keep the third variable as constant. Okay, so I'll also tell you when this happens. This happens when it is of this form, when all the 3 variables are of this form. Okay, which form? It should be of this form. Okay, art form. A is equal to RT. So in this form, you can say you can keep the third variable as constant and then try to vary the other things. Okay, so if the 3 variables are not of this form, even then you can try. Okay, but usually it is done like this. Okay, but the important thing you have to understand here is, if you have 3 variables, keep the third one as constant. Okay, and see and vary one of those variables and see how the second variable reacts to it. Okay, so here time is directly proportionate to work done. Okay, it is work done, guys, not work done per hour or work done per day. Okay, now work done per hour or work done per day is efficiency. That is what we kept as constant in this equation. So next is going to be time and efficiency. So we are going to look at the relationship between time and efficiency, and it says they are indirectly proportionate. So we'll find out. So efficiency is also known as rate of work and one work done per hour. Now you have to keep work done of eating 8 chocolates as constant, guys. So here work done is going to be constant. So time, half a minute, 1 minute, 2 minutes, efficiency. Now half a minute, okay, he eats 8 chocolates. Okay, so what is his efficiency? It is 16 chocolates per minute, right? Only if his efficiency is 16 chocolates per minute, he'll be able to eat 8 chocolates in half a minute. Okay, so that is the efficiency. Now, 8 chocolates per minute. Okay, so for if it is 1 minute, his efficiency should be 8 chocolates per minute, correct? That will make it possible for him to eat all the 8 chocolates. Okay, here the work done is constant. So 2 minutes, then it should be 4 chocolates per minute. Okay, so if he takes 2 minutes to eat those 8 chocolates, what does it mean? It means his efficiency is 4 chocolates per minute. So this is what is going to give us the relationship between time and efficiency, guys. So here, time and efficiency, how do you find the relationship? So I'd say, to find the relationship between time and efficiency, see what happens when you increase the time. Okay, what is happening to efficiency? It is decreasing. Yes, when you increase the time, the efficiency is decreasing. Okay, so it is strange. If you decrease the time from half to 1 to half minute, so what's happening is, if you decrease the time, the efficiency is increasing. Yes, from 8 it becomes 16. Okay, so now this is what we call as indirectly proportionate. Okay, this is an exact case of indirectly proportionate, guys. So what we'll do is, so we'll yes, as time increases, efficiency decreases, and as time decreases, efficiency increases. Both of this happens under constant work done. Okay, so this tells us time is indirectly proportionate to efficiency, or work done per hour. Okay, or it could be work done per minute or work done per day. Okay, it is just a unit of time. So you guys know efficiency is also work done per hour. So we'll look at the final relationship, guys. Work done is directly proportionate to efficiency. This time we are going to keep time as constant. So let us keep the time of 3 hours as constant and do the same thing. So we'll have work done as 6, 12 and 18. Now 3 hours is constant. For 2 chocolates per hour efficiency, if he eats for 3 hours, what do you think will happen, guys? He'll eat 2 chocolates, right? Yes. Now what we'll do is, we'll increase the efficiency, 4 chocolates per hour. What will happen? If he eats for 3 hours, he'll eat 12 chocolates. Now increase it again, 8 chocolates per hour. Okay, if he eats for 3 hours, he'll eat 24 chocolates. Okay, so guys, this shows when you increase the efficiency, then work done also increases. When you decrease the efficiency, work done also decreases. This is the reason why we say work done is directly proportionate to efficiency under constant time. So we can tell you the final result, which is, as time increases, efficiency decreases. As It should be the other way around, guys. As the work done increases, efficiency decreases. As the work done decreases, efficiency increases. Okay, there is a little error here. Okay, so what I'll do is, I'll come back. Just a minute, guys. So this is it, guys. So as the work done increases, efficiency increases under constant time. Similarly, as the work done decreases, efficiency decreases under constant time. So this is why we say work done as directly proportionate to efficiency under constant time, of course. Okay, so you can see work done is directly proportional to efficiency, or work done per hour. Okay, so hope you got this. Okay, again, efficiency is also known as rate of work and work done per hour or day. Now let us suppose, guys, if a work is completed in 10 days. Okay, so you have to assume that some work, okay, it can be any work. Okay, or it could be cutting down 100 trees. Okay, so if a work is completed in 10 days, then 1 day's work is 1 by 10. Am I right? Yes, because if he completes cutting down 100 trees in 10 days, in 1 day, how much of the trees will he cut? Okay, so let us say 100 trees is being cut in 10 days, right? He says that the work is completed in 10 days. So 100 trees is cut in 10 days. So in 1 day, how many trees will be cut? So 10 trees is cut in 1 day, right? So 10 trees is cut in one day. So in one day, what is the amount of work done? 10 is 1 by 10th of 100, right? So the amount of work done is 1 by 10th. Okay. So this is very important. You have to know what all this means, right? So then the work done is 1 by 10. Now, the work per day is the rate of work, or in other words, this 1 by 10, guys, is the rate of work. And what else can we call this by? This 1 by 10, we can call it by efficiency. You can also call this efficiency. This 1 by 10, you can also call rate of work. And this 1 by 10, you can also call work done per hour or work done per day. Okay, so any three of those three names you can use to describe this 1 by 10. Okay, so the time taken here is 10 days. Rate of work is 1 by 10. Okay. Now, most of you will be surprised to know this work here, guys, actually indicates this rate of work. Okay, not the work done. Okay, it is not the work done. This work here, this time and work, this work here indicates the rate of work. Okay, that is what they are trying to imply. Okay, so one day's work is 1 by 10, guys. Now, in general, if one day when converted to 1 by 10, okay, this one day is time, right? One day is time. When converted to 1 by 10, which is work per day, okay, 1 by 10 is the efficiency, right? 1 by 10 is the efficiency, rate of work, work per day, whatever you want to call it, okay, gets inversed. Okay, one, how did 1 become 1 by 10? Okay, again there is a mistake here. This is not one day, sorry guys, this is 10 days. Okay, so what I'll do is I'll just change it into 10 days. So this is actually 10 days. So what happens is 10 days when converted to rate of work, okay, rate of work or work per day or efficiency, whatever you want to call it, 10 days when converted to efficiency, it becomes 1 by 10. Okay, now what is the reason it gets? How did 10 become 1 by 10? Or in other words, you are reversing it, right? You are inversing 10. Okay, why do you inverse 10? It is because time and efficiency are inversely proportionate. Okay, we just saw in a couple of sides, we saw that back couple of slides back. Yes, what did we see? Time is inversely proportionate to work per day or efficiency. Okay, so that is why 10 days becomes 1 by 10. And for the same reason, guys, okay, therefore 1 by 10 is one day's work, then the work will be completed in 10 days. Okay, so when you convert efficiency to time, then also it will get inversed. Okay, so you see here 1 by 10 is becoming 10 days. So if somebody says my one day's work is 1 by 10, he is going to complete that work in 10 days. Okay, so efficiency, rate of work, you inverse it, you will get time. Okay, time you inverse it, you will get efficiency and rate of work, efficiency or rate of work. Okay, and what is the reason? It is because of the inverse relationship, inversely proportionate relationship between time and work. Okay, and 1 by 10, you know, guys, is rate of work. Okay, now you also know 1 by 10 is 10 percentage. Yes, 1 by 10 is 10 percentage, guys. Usually when they try to express efficiency, they'll express it this way. Okay, they'll express it using 10 percentage, using percentage terms. Okay, they won't say the efficiency is 1 by 10, they'll say the efficiency is 10 percentage. Okay, now the reason is simple. Usually percentages refer to efficiencies. Efficiencies are written in percentages and ratios. Okay, so percentages, ratios. I want you to understand fraction, percentage, ratio, guys. It is three different ways of representing the same thing. Okay, fraction 1 by 10, 10 percentage, and ratio. Okay, 1 is to 10 is the ratio here. Okay, all these are the same things, say representing same things. Okay, these are they are very closely related, fractions, percentages, and ratios. Okay, so if a is the so let's look at this question. So let's look at this question. If a is thrice as efficient as b, okay, what does it mean? A is thrice as efficient as b. It means if b does eats one chocolate, A can eat three chocolates, correct? Or look at this case. If A's efficiency is 30 percentage, correct? If A's efficiency is 30 percentage, B's efficiency will be 10 percentage. Okay, that is thrice, right? Because A is thrice as efficient as B. Whatever is B, 3 times is A. So if B is 10 percentage efficient, A will be 30 percentage efficient. So if I ask you what is the efficiency ratio of A and B, you have to do just 30 is to 10. Okay, what is 30 is to 10? 3 is to 1. Okay, so the efficiency ratio of A is to B is 3 is to 1. So welcome back, guys. So I was talking about the correspondence between time and work and time, speed, and distance. So let us look at that. So we know distance is equal to speed into time. Okay, for those of you who don't know what this means, let us take an example of okay, the speed at which somebody travels is 45 kilometers per hour. Okay, so this is the speed at which somebody travels, 45 kilometers per hour. The time that they travel for is 2 hours. Now, what do you think will happen to the distance travel? Distance travel is nothing but 45 into 2, which is 90 kilometers, right? Yes. So this is the meaning of this formula. Okay. So when they say distance is equal to speed into time, it is 45 kilometers per hour into hour. Okay. Now just look at this, guys. Look at the units: kilometer per hour, hour. This hour and this hour will get cancelled. When you multiply this and this will get cancelled, you will be left with what? You will be left with just kilometers. So that is why we have just kilometers here. Okay. Now 45 into 2 is 90. So that is why we have 90 kilometers. So this is a very important formula in time, speed, and distance. We cannot do any problem in time, speed, and distance without this formula. Okay, so I'm just giving you a forewarning. Okay, make sure that you know this formula. Okay, now how is this related to time and work? So we'll have a look at that. See, we could write this as distance is the work done, speed is the rate of work, and time is time. Okay, how is distance equal to work done? It is equal to work done because here total work done is the total distance travel. Okay, the work that you're doing is the distance that you're traveling, right? That is the work that you're doing. Okay, let us take, you take a car and cover a distance of 100 kilometers. Now what you've done is you've done the work of traveling 100 kilometers. Okay, so that is the work that is done. So here the total work done is the total distance traveled. Okay, now you, by now you would have guessed it. Rate of work is nothing but the speed, right? So I go 100 kilometers, but at what speed do I go cover 100 kilometers? At speed of 20 kilometers per hour maybe, okay, or 30 kilometers per hour. Okay, so that is the speed. So that is the rate at which that work is being done. What is that work? The work is covering 100 kilometers. Okay, so the rate at which I am covering 100 kilometers is the rate of work. In other words, it is the speed. Okay, and time is time. Okay, there is no change in time. Okay, so here you can see how this, guys, this do you remember the, I gave you a very specific name for this equation. Work done is equal to rate of work into time. Do you remember it? If you remember it, just put it in the comment section. Okay. I'm curious how many of you still remember that name. Okay. Just put it in the comment section, guys. Okay. There is a very specific name I gave for this formula, which is work done is equal to rate of work into time. Let's see how many of you remember it. So moving on. So if by traveling at a speed of 45 kilometers per hour for 10 hours, one is able to cover 450 kilometers, guys. So the speed is 45 kilometers per hour, and it is for 10 hours. And you know the distance into time will give you, sorry, speed into time will give you the distance, right? The speed is 45 kilometers per hour and the time is 10 hours. So you'll have 45 into 10, which is 450 kilometers. Okay, here the rate of work done is 45 kilometers per hour. As I told you, speed is the rate of work. Okay, the work is, which is speed at which the distance is covered. Correct. Here the rate of work is nothing but the speed at which the distance is covered, right? So here the work done is 450 kilometers. Okay, so what is the achievement? What is the achievement that you've done? You've done 450 kilometers. You covered 450 kilometers. That is the work. Okay, so that is the work done. So you could put it in the formula like this, guys. And if you put it in this is no more distance equal to speed into time. This has become work done is equal to rate of work into time. Now this is how you have to understand that time and work and time, speed, distance is born out of the same basic equation. Moving on. Okay, we'll come to this fractional method. Okay, so this is one of the methods that I told you that you must be learning and understanding well. Okay, so pay close attention to this fractional method. This is one of the methods which is used to solve time and work problems, guys. If you do a work in 2 days, complete any work in 2 days, how much of the work will you do in one day? I want answers in fractions, guys. Fraction. In a fraction, what is the whole? In a fraction, the whole is always 1. Okay, when the whole is 1, if a work can be completed in 2 days, what is the amount of work that will be completed in one day? Okay, so this is why it is called fractional method, because we are dealing with fractions here. Okay, so amount of work completed in one day is half of the work. Correct? Yes, first day half of the work. This is amount of work completed in one day. Correct, guys? Yes. What is the amount of work completed in the second day? Half of the work. Okay, so half plus half will give you what? 1. So in fractional method, you have to understand that the total work is always 1. Okay, look at this, the large circle that I've drawn. Okay, here you find that the total work is always 1. The total work is always 1. Okay, this is very important you understand that in the fractional method. Okay, the total work is always 1. What is half plus half, guys? Half plus half is 1, right? So a work is being completed in 2 days. First day, half of the work will be completed. Second day, the remaining half of the work will be completed. Okay. See here, what we are assuming is we are assuming the efficiency to be the same. At no place in this 2 days is the efficiency changing. How do you know it? How do you know the efficiency is not changing? Look at this. What is this half, guys? This half is nothing but the efficiency, right? Half is nothing but work done per day. I've told you another name for efficiency is work done per hour or work done per day. Correct? So this half is the work done per day. So in the first day also it is half, in the second day also it is half. So is efficiency changing? No. So this holds true, all this discussion holds true when the efficiency is not changing. Okay. So you'll see each day the efficiency will be the same. First day it is half, second day it is half. Okay. Or should I say half? How do you usually represent efficiency? Efficiency is represented in percentage. What is half in percentage? 50 percentage. So first day the efficiency is 50 percentage. Second day it is 50 percentage. So add 50 plus 50, you'll get 100 percentage, and the total work will be done. Okay. So that is what the meaning of all this is. Now if a work is completed in 3 days, now what happens if a work is completed in 3 days? First day 1 by third of the work will be done, am I right? Second day again 1 by third of the work will be done. Third day again 1 by third of the work will be done. Now look at the efficiency. Is it the same all the 3 days? Yes, the efficiency must be constant. Okay, only when the efficiency is constant you can say for sure that he will do 1 by third of the work first day, 1 by third of the work second day. If the efficiency is varying, you cannot say this for sure. Okay, if the efficiency is varying, guys, see, first day he might do 1 by fourth of the work. Okay, he feels a little tired, so second day he just does let us say first day we'll take half of the work. Okay, first day he does half of the work, second day is a little bit tired, so what he does is he just does 1 by fourth of the work. Okay, now third day he maintains his efficiency. Now his efficiency differs. First day he was very efficient, but second and third days he is only half efficient. Okay, now see, the efficiency is differing. Now in this case you cannot have this. Okay, you can only have this first day 1 by third of the work, second day 1 by third, third day 1 by third. Okay, the rate of work will be the same and the efficiency is same, and it makes sense, right? He's doing each day his efficiency is same, the effort which he is doing a work is same. So the total work again here is, guys, 1 by 3 plus 1 by 3 plus 1 by 3, you'll get 1. So it is the same thing. If a work is completed in 4 days, now I want you to pause the video and then fill in the blanks. Okay, first day how much of the work will be done, second day, third day, and will be there be a fourth day, or will there be a fifth day? Okay, so I want to pause the video and answer this question and then come back and check your answer. Yes, pause the videos, guys. See, if a work is done in 4 days, what will be the first day's work? In first day, he'll complete 1 by fourth of the work. Second day, it will be again 1 by 4. Third day, it will be 1 by 4. And the final day, fourth day, it will be 1 by 4. Now, how do you know the work is completed? It is because 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 is 4 by 4, which is 1. Okay, again, we've reached the total work, which is 1. This important thing, okay, I cannot stress enough of the importance of you guys knowing that in fractional method the total work is always 1. Okay, now why is this important? I'll tell you. Okay, in a problem they'll say somebody completed 5 by 12th of the work. Okay, so somebody completed 5 by 12th of the work. Okay, now you have to find what is the remaining work, and using that you will have to take it from there and move on. Okay, move on and finally finish the problem. But if you have to continue, you have to know what is the amount of work that is left. Okay, see, 5 by 12th of the work is completed, so what is the amount of work that is left? I'd say it is 1 minus 5 by 12. Okay. Now, where did this 1 come about? Any answers? Where did this 1 come about? This 1 is the total work, guys. This 1 is the total work. That is why I am subtracting 1 minus 5 by 12. Okay, total work minus the work that is completed will give me the remaining work. Okay, total work minus the work that is completed will give me the remaining work. Okay, so only if I know the remaining work, I will be able to proceed. Okay, so I'll find it using this method 1 minus 5 by 12, which is 7 by 12. Okay, after some practice, you don't need to use this one, guys. See, this answer for this is actually 7 by 12. The remaining work, if you, it will come to around 7 by 12. Okay, after some practice, what you do is you just subtract these two things. What is 12 minus 5? 7, right? So put that 7 in the numerator and put the same thing, same 12 in the denominator. Okay, that's it. So that is your remaining work. If you did not understand what I meant, if 2 by 5 is the amount of work that is done, the remaining work is nothing but what is 5 by 5 minus 2? 5 minus 2 is 3. Okay, divided by what is in the denominator? 5, right? 5. So this is the work that is completed. This is the work that is remaining. Okay, so you don't need to do 1 minus this. Even if you do 1 minus 2 by 5, you'll get 3 by 5 only. Okay, but just a shortcut. Okay, this shortcut you can just apply it to get the remaining work. Okay, so I'll give you one more example so that I don't want anybody to miss out on this. So let's say 7 by 15. Okay, now the 7 by 15 is completed. What is not completed? 15 minus 7. Okay, I will do 15 minus 7. What is 15 minus 7? 8. Okay, 8 divided by, write down the same denominator. Okay, so if 7 by 15 is the work that is completed, the incomplete work is 8 by 15, or the remaining work is 8 by 15. Okay, so if a work can be completed in n days, each work, each day's work will be 1 by n. Okay, so this is not very hard to comprehend, guys. Look at this. If a work is completed in 2 days, each day's work is 1 by 2. If a work is completed in 3 days, each day's work is 1 by 3. If a work is completed in 4 days, each day's work is 1 by 4. So you can just generalize, if a work can be completed in n days, each day's work is 1 by n. If a work can be completed in n days, each day's work is 1 by n. So I hope we've established this. Now what we have to understand is the converse of this is also true. Okay, what is the converse? If each day's work is 1 by n, then the work can be completed in n days. Okay, if each day's work is 1 by n, then the work can be completed in n days. Okay, so if this I am putting at the first. Okay, so or this I am assuming, if each day's work is 1 by n, then the work can be completed in n days. Okay, so that is what here it is mentioned. So the converse of this. Okay, if you're able to complete a work in 2 days, 1 day's work is 1 by 2. If 1 day's work is 1 by 2, you'll be able to complete the work in how many days? 2 days. Okay, if 1 day's work is 1 by let's say 1 by 5. Okay, 1 by 5 is 1 day's work. You'll be able to complete this work in 5 days. Let's say 1 day's work is 1 by 18. You'll be able to complete this work in 18 days. Let's say the 1 day's work is 55 by 99. Okay, this is nothing but 5 by 9. Yes, so if 5 by 9 is the 1 day's work, you'll be able to complete this work in 9 by 5 days. Okay, you just have to do the inverse. Okay, 55 by 67. If 1 day's work is 55 by 67, this work will be completed in 67 by 55 days. Okay, so don't try to convert this into decimal values. Usually they won't ask you to find decimal values. The answers will be in fractions. So a common mistake that I often find people doing is, so let us take an example and see how it is done. So Dheeraj alone can do a work in 10 days, okay, and Suraj alone can do the same work in 15 days. Now working together, how many days will Dheeraj and Suraj take to complete the work? Okay, so this is the question, guys. So there is a work, okay, we'll never know what that work is, okay, but they'll often talk about a work, okay. So here a work is being done by Dheeraj. If that work is done by Dheeraj alone, he is not taking any help. So he is doing it alone. When Dheeraj is doing it alone, he'll complete the work in 10 days. Now when Suraj is doing, Suraj is not taking help from anybody. He is doing it alone. Now when Suraj does the work, he does it in 15 days. Okay. So working together, how many days will Dheeraj and Suraj take to complete the work? Okay. Right now, Dheeraj and Suraj are working together. Okay. Now how long will it take? Okay. Now let us see the common mistake first, and then I will tell you how to do this problem. So first, Dheeraj alone can do a work in 10 days. Okay, there is no problem with this. Okay, I've just taken down the statement, or I've just taken down the given from the question and then put it there for you to see. Dheeraj alone can do a work in 10 days. Okay, so there's nothing wrong with this. So there is a tick mark. Okay, now again, Suraj alone can do the same work, guys. It is the same work. So you have to pay close attention here. The work is not some other work. It is the same work that Dheeraj did. Okay, it is the same work that Dheeraj did. So Suraj does the same work in 15 days. Okay. Now you tell me, I'm going to ask you a basic question. Now Dheeraj, it is the same work. Dheeraj is taking 10 days. Suraj is taking 15 days. Who do you think is more efficient? Who do you think is more efficient at doing this work, guys? Is it Dheeraj or Suraj? Who is very efficient? Whoever takes the less amount of time, they are efficient, right? So who is taking the less amount of time? It is Dheeraj. Okay. So this guy is the efficient guy. Suraj takes 15 days. He is not efficient. Okay. I mean, compared to Dheeraj, he is not efficient. So between these two, who is efficient? Dheeraj is efficient. Suraj is less efficient than Dheeraj. Okay. Just keep this thing in mind. Now, so usually what people do is, okay, so do Dheeraj and Suraj, they do this together. So they do 10 plus 15, 25 days. They say 25 days. They both complete together in 25 days. Now, is this correct? Dheeraj and Suraj together, working together, they complete it in 10 plus 15, 25 days. Is this correct, guys? It is wrong. Okay, it is wrong because of the basic thing. Okay, see, there is a work. Dheeraj is able to complete it in 10 days. Suraj is able to complete it in 15 days, right? This is working alone. When they join together, will it be less than 15 or more than 15? See, Suraj alone can do the work in 15 days. Correct? Suraj will do it in 15 days, guys. Now, if he gets help from Dheeraj, obviously he is going to complete the work with inside of those 15 days, right? Yes, you're able to understand what I'm trying to say here. Yes. See, Suraj, he is able to complete the work in 15 days. Okay. Now he is getting help from Dheeraj. Okay. From Dheeraj. Now once he gets this help, guys, now both these guys, will they complete the work before 15 days or after 15 days? Obviously it should be before 15 days, right? After help from Dheeraj, the days must be less than 15. Okay, but how much did you get here? See, 25. So obviously there is something basically wrong with this method. Okay, I'd say it is not the method, it is the way you substituted the things that you added. Okay, here what you added is, yes, Dheeraj and Suraj, they do together, and they do together, you cannot add the time. Okay, you must be adding the rate of work, or you must be adding the efficiency, or you must be adding the work done per day. Okay, so these things you should be adding, not the time. You shouldn't add the time. This is a very common mistake that I often see in time and work problems, guys. As a rule, never add times. Okay, never ever add times in time and work problems. Okay, it is going to give you invariably the wrong results. Okay, never ever add time. Okay, I'll tell you the reason in the next slide. So so I'm going to put you the same, give you the same question. Dheeraj alone can do a work in 10 days and Suraj alone can do the same work in 15 days. Working together, how many days will Dheeraj and Suraj take to complete the work? Now, Dheeraj alone can do the work in 10 days. Because you know, if somebody can complete a work in 10 days, what is the rate of work? Dheeraj takes or 1 day's work, 1 day's per day work is rate of work, right? Per day work, per hour work. Okay, what is kilometers per hour? It is speed. Okay, speed, rate of work, all these things are the same things. Okay, so the rate at which the work is being done is the rate of work. Okay, the rate at which the vehicle is moving is the speed of the vehicle. So Dheeraj 1 day's work is 1 by 10. Okay, so 1 day in 1 day he does 1 by 10. So you know this, right? So here you can see work time is being converted to work. That is how people usually say. I'd say time is being converted not into work. Time is being converted into efficiency or rate of work. You don't say work. Okay, time is being converted to rate of work. Okay, it is not work. Okay, that is why people get confused. People often ask me, sir, what is the relationship between time and work? Is it directly proportionate and indirectly proportionate? They give me proof after proof which says time and work are directly proportionate. Yes, if you have more time, you will be able to do more work, right? Yes, more work, more time. Yes, so then it is directly proportional. Less work, less time, right? It is directly proportionate. Yes, what they are saying is they're talking about the work done. If you have more time, you will get more work done. Okay, but here what we are referring to is not work done. Okay, here what we are referring to is, guys, is work, rate of work. That is why 10 is becoming 1 by 10, because they are inversely proportionate. Time and work done are directly proportionate, but time and work done per hour, which is rate of work, which is efficiency, is inversely proportionate. Okay, so now you understand. So if anybody asks you what is the relationship between time and work, you ask them, by work what do they mean? Do they mean the work done, or do they mean rate of work? Okay, so it depends upon that. Okay, depending, if it is the relationship between time and work done, they are directly proportionate. If it is a relationship between time and efficiency or work done per hour, they are inversely proportionate. So that is why, so 10 days becomes 1 by 10. So let's see what happens to Suraj. So Suraj does his work in 15 days. So his 1 day's work is 1 by 15. Now, Dheeraj and Suraj in 1 day will do how much of work? Okay, so this is Dheeraj's 1 day work, 1 by 10. So this is Suraj's 1 day work, 1 by 15. So look at this. This is Dheeraj's 1 day work. This is Suraj's 1 day work. So Dheeraj and Suraj 1 day work is nothing but this plus this. So we'll add 1 by 10 plus 1 by 15. See what we are adding? We are not adding the time. We are actually adding the efficiency. We are actually adding the rate of work. We are actually adding the work done per day. Okay, in time and work you always add the rate of work. You always add the work per day. Okay, you never add the time, guys. So make sure that you understand this. Okay, now what I've done is I'm adding the work done per day. So I'm getting 1 by 6. What is this 1 by 6? 1 by 6 is Dheeraj and Suraj just 1 day work. Now you know the converse of this. 10 days, 1 day work is 1 by 10. If it is 1 day work is 1 by 10, it will take 10 days. Correct? Converse. Similarly, if both of them's 1 day work is 1 by 6, both of them will complete it in 6 days. Correct? So Dheeraj and Suraj together can do the same work in 6 days. So the reverse inverse of 1 by 6 is 6. Yes, we saw the converse theory, right? Yes. So Dheeraj can do the work in 10 days. So Dheeraj's 1 day's work will be 1 by 10. Okay. Now what is the converse? If Dheeraj's 1 day's work is 1 by 10, Dheeraj will complete it in 10 days. Now we are inversing. 1 by 10 inverse will get you 10. Similarly, Dheeraj and Suraj's 1 day's work is 1 by 6. Then Dheeraj and Suraj's time will be inverse of 1 by 6. So inverse of 1 by 6 will give you 6 days. See, now this is correct. Okay. Always add the rate of work and not the time in these problems. We never add the given time periods in time and work. By time periods, what I mean is this 10 days and 15 days, guys. We never add them. Okay. Under any circumstances, don't ever add the time. Okay. So I just want to make sure that you do it.